When installing a new cable tray system above an existing one, it is crucial to adhere to the National Electrical Code, or NEC, and relevant electrical standards. These codes and standards dictate the minimum allowable distance between cable trays to ensure safety, proper cable management, and ease of maintenance. NEC 392.14 C2 specifically addresses the vertical spacing between cable trays. When installing a new cable tray above an existing one, NEC 392.14 C2 mandates that the new tray must be positioned no less than 6 inches, equivalent to 152 mm, above the existing tray. This 6-inch minimum distance is designed to provide adequate clearance for cables and other components housed within the tray system. This clearance is essential for several reasons. Firstly, it allows sufficient space for proper cable bending radii, preventing damage to the cables and ensuring optimal performance. Secondly, it facilitates cable termination and maintenance, making it easier to access and work on individual cables without disturbing the entire system. Thirdly, adequate clearance helps prevent overheating by allowing for sufficient air circulation around the cables. NEC 392.17d outlines the support requirements for cable trays installed vertically or at an angle of 45 degrees or less from vertical. According to NEC 392.17d, these cable trays must be supported at intervals not exceeding 6 feet, or 1.8 meters. This requirement ensures that the cable tray is adequately supported, preventing sagging or collapse due to the weight of the cables. Proper support is critical for maintaining the structural integrity of the cable tray system and ensuring the safety of personnel working around it. NEC 392.24 specifies the support requirements for cable trays in general. NEC 392.24 states that cable trays must be securely supported by hangers, brackets, or other approved means. The maximum support intervals vary depending on the type of cable tray. For solid bottom trays, the maximum support interval is 5 feet, or 1.5 meters. For ventilated trays, the maximum support interval is 10 feet, or 3.0 meters. These support intervals are designed to provide adequate support for the cable tray and the cables it carries, preventing sagging or deformation of the tray. It is crucial to adhere to these support requirements to ensure the long-term reliability and safety of the cable tray system. Beyond the NEC requirements, industry best practices and recommendations offer additional guidance on cable tray spacing. The National Electrical Contractors Association, or NEC, recommends a minimum distance of 12 inches, or 305 mm, between cable trays. This recommendation goes beyond the NEC minimum of 6 inches and provides even greater clearance for cable management and maintenance. The increased spacing allows for easier cable routing, termination, and troubleshooting. It also provides more room for future expansion or modifications to the cable tray system. While the NEC recommendation is not a mandatory code requirement, it represents a valuable guideline for ensuring optimal cable tray performance and maintainability. When installing a new cable tray above an existing one, it is essential to consider several factors to ensure the system is properly supported and can safely handle the additional load. Firstly, consider the cable routing. Plan the cable routing carefully to minimize stress on the cables and ensure they can be easily accessed for maintenance. Avoid sharp bends or excessive pulling on the cables, as this can damage the insulation and reduce their lifespan. Secondly, consider the cable size. Ensure that the cable tray is adequately sized to accommodate the cables that will be installed in it. The cable tray should be able to support the weight of the cables without sagging or deformation. Thirdly, consider the weight of the cables. Calculate the total weight of the cables that will be installed in the cable tray and ensure that the tray supports and hangers are capable of supporting this weight. Overloading the cable tray can lead to structural failure and pose a safety hazard. Local codes and regulations may have additional requirements for cable tray installations. It is essential to consult with local authorities and refer to the applicable electrical codes and standards to ensure compliance. These codes and standards may vary depending on the specific application and location. Failure to comply with local codes and regulations can result in fines, delays, or even the shutdown of the electrical system. The NEC provides comprehensive guidelines for cable tray installations, covering various aspects such as spacing, support, grounding, and conductor fill. NEC 392 covers cable trays in detail, providing requirements for construction, installation, and use. It is essential to familiarize oneself with NEC 392 before installing a cable tray system. NEC 392 addresses topics such as cable tray materials, allowable ampacity of conductors in cable trays, and methods for grounding cable trays. Adhering to these requirements ensures that the cable tray system is installed safely and reliably. Proper planning is crucial for a successful cable tray installation. Before beginning the installation, develop a detailed plan that outlines the cable tray layout, support locations, and cable routing. This plan should take into account the NEC requirements, the industry best practices, and any specific requirements of the installation. A well-developed plan helps minimize errors, reduces installation time, and ensures that the cable tray system meets all applicable requirements. During the installation process, it is important to use proper tools and techniques. Use cable tray cutters to cut the cable tray to the required length, and use cable tray benders to create bends in the cable tray. Use cable ties or cable clamps to secure the cables to the cable tray, preventing them from moving or sagging. Always follow the manufacturer's instructions when installing cable tray components. After the installation is complete, thoroughly inspect the cable tray system to ensure that it meets all applicable requirements. Check the cable tray spacing, support locations, and cable routing to ensure that they are in accordance with the NEC and industry best practices. Verify that all cable tray components are properly installed and secured. Address any deficiencies or issues that are identified during the inspection. Regular maintenance is essential for ensuring the long-term reliability of a cable tray system. Inspect the cable tray system periodically for signs of damage or deterioration. Check the cable tray spacing, support locations, and cable routing to ensure that they are still in accordance with the NEC and industry best practices. Clean the cable tray system to remove dust, dirt, and debris that can accumulate over time. Replace any damaged or worn components. Proper maintenance helps prevent problems and extends the life of the cable tray system. Grounding is an important aspect of cable tray installations. The NEC requires that cable trays be properly grounded to prevent electrical shock hazards. Grounding ensures that the cable tray is at the same electrical potential as the surrounding equipment, minimizing the risk of electrical shock in the event of a fault. Follow the NEC requirements for grounding cable trays, using approved grounding methods and materials. Proper grounding is essential for electrical safety. Conductor fill is another important consideration when installing cables and cable trays. The NEC limits the number of conductors that can be installed in a cable tray to prevent overheating and ensure proper ventilation. The allowable conductor fill depends on the size of the cable tray and the type of conductors being installed. Refer to the NEC tables for conductor fill to determine the maximum number of conductors that can be installed in a cable tray. Overfilling a cable tray can lead to overheating and potential fire hazards. Cable tray systems offer numerous advantages over other wiring methods. They provide a flexible and adaptable solution for supporting and routing cables. Cable trays can be easily modified or expanded to accommodate changing needs. They also provide excellent access to cables for maintenance and troubleshooting. Cable tray systems are a cost-effective and reliable solution for a wide range of applications. When selecting a cable tray system, consider the specific requirements of the installation. Choose a cable tray material that is suitable for the environment in which it will be installed. Consider the load-bearing capacity of the cable tray and ensure that it can support the weight of the cables. Choose a cable tray width and depth that is adequate for the number and size of cables that will be installed in it. Select cable tray accessories that are compatible with the cable tray system. Working with qualified professionals is crucial for ensuring a safe and compliant cable tray installation. Consult with a licensed electrical contractor or engineer to design and install the cable tray system. These professionals have the knowledge and experience to ensure that the cable tray system meets all applicable requirements. They can also provide guidance on cable tray selection, installation techniques, and maintenance procedures. Investing in professional services helps ensure a safe and reliable cable tray system. In summary, installing a new cable tray system above an existing one requires careful consideration of the NEC requirements, industry best practices, and the specific requirements of the installation. Adhering to the NEC minimum spacing requirements, utilizing industry best practices for cable management, and planning carefully can help ensure a safe, reliable, and maintainable cable tray system. Remember to consult with local authorities and qualified professionals to ensure compliance with all applicable codes and regulations. By following these guidelines, one can successfully install a cable tray system that meets the needs of the installation and provides years of reliable service. In addition to the NEC and NEC guidelines, it is important to consider the specific environmental conditions when determining the minimum allowable distance between cable trays. In areas with high humidity or corrosive environments, it may be necessary to increase the spacing between cable trays to prevent corrosion and ensure proper ventilation. The type of cables being installed in the cable trays can also impact the required spacing. Cables with larger diameters or higher heat dissipation requirements may require more spacing to prevent overheating. It is also important to consider the future expansion of the cable tray system. If there is a possibility that additional cables will be added in the future, it is wise to provide extra spacing between cable trays to accommodate these future needs. Planning for future expansion can save time and money in the long run by avoiding the need to relocate or modify the cable tray system. When installing cable trays in areas with limited space, it may be necessary to use specialized cable tray designs such as ladder cable trays or wire mesh cable trays. These cable tray designs can provide more efficient cable management in tight spaces. It is also important to consider the accessibility of the cable trays for maintenance and repairs. Ensure that there is sufficient clearance around the cable trays to allow for easy access for troubleshooting and repairs. In some cases, it may be necessary to install access panels or platforms to provide access to hard-to-reach cable trays. Proper labeling of cables and cable trays is essential for efficient maintenance and troubleshooting. Use cable markers to identify each cable and cable tray labels to identify the purpose and location of each cable tray. Clear labeling can save time and reduce errors during maintenance and repairs. Regular inspections of cable tray systems are essential for identifying potential problems before they become major issues. Inspect the cable trays for signs of corrosion, damage, or overloading. Check the cable supports and hangers to ensure that they are securely attached and properly aligned. Inspect the cables for signs of damage or wear. Address any identified problems promptly to prevent further damage or potential safety hazards. Cable tray systems are an integral part of many electrical installations. By following the NEC requirements, industry best practices, and the specific requirements of the installation, one can ensure a safe, reliable, and maintainable cable tray system. Remember to consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations. With proper planning, installation, and maintenance, cable tray systems can provide years of reliable service. There are various types of cable trays available, each with its own unique characteristics and applications. Ladder cable trays are characterized by two longitudinal side rails connected by rungs, resembling a ladder. They offer excellent ventilation and are suitable for supporting heavy cables over long spans. Ventilated trough cable trays have a solid bottom with ventilation openings to allow for air circulation. They provide good support for cables and are commonly used in general-purpose applications. Solid bottom cable trays have a completely solid bottom, providing maximum protection for cables. They are suitable for applications where cables need to be shielded from dust, dirt, or moisture. Wire mesh cable trays are constructed from welded wire mesh, offering excellent ventilation and visibility. They are lightweight and easy to install, making them ideal for applications where flexibility is required. Single-rail cable trays, also known as I-beam cable trays, consist of a single central rail with support arms extending outwards. They are commonly used for supporting cables in vertical runs. When selecting a cable tray, It is important to consider the type of cables being supported, the environmental conditions, and the load-bearing requirements. The cable tray should be made of a material that is compatible with the environment and capable of supporting the weight of the cables. The cable tray should also provide adequate ventilation to prevent overheating of the cables. In addition to the NEC and NEC guidelines, there are other industry standards that provide guidance on cable tray installations. The Institute of Electrical and Electronics Engineers, or IEE, publishes standards related to cable tray design, installation, and testing. These standards provide valuable information on topics such as cable tray grounding, bonding, and conductor ampacity. Consulting these standards can help ensure that the cable tray system is installed in accordance with best practices. The selection of cable tray supports and hangers is critical for ensuring the structural integrity of the cable tray system. The supports and hangers must be capable of supporting the weight of the cable tray and the cables it carries. They must also be properly installed and securely attached to the building structure. There are various types of cable tray supports and hangers available, including trapeze hangers, wall-mounted brackets, and floor-mounted supports. The selection of the appropriate supports and hangers depends on the specific application and the load-bearing requirements. Proper cable management within the cable tray is essential for preventing cable damage and ensuring efficient maintenance. Cables should be neatly arranged and secured to the cable tray using cable ties or cable clamps. Avoid overcrowding the cable tray with cables, as this can restrict ventilation and make it difficult to access individual cables. Cables should be routed in a way that minimizes stress and prevents sharp bends. When installing cables in a cable tray, it is important to follow the manufacturer's instructions for cable installation. The cables should be properly supported and secured to the cable tray to prevent sagging or movement. The cable should also be protected from damage during installation. Use cable rollers or cable pulling grips to avoid pulling the cable excessively. After the cable tray system is installed, it is important to perform a thorough inspection to ensure that it meets all applicable requirements. The inspection should include a visual examination of the cable tray, supports, and cables. The inspection should also include electrical testing to verify that the grounding and bonding are properly installed. Any deficiencies or issues identified during the inspection should be corrected promptly. Regular maintenance of the cable tray system is essential for ensuring its long-term reliability and safety. The cable tray should be inspected periodically for signs of corrosion, damage, or overloading. The cable supports and hangers should be checked to ensure that they are securely attached and properly aligned. The cable should be inspected for signs of damage or wear. Any identified problems should be corrected promptly. Cable tray systems are a versatile and cost-effective solution for supporting and routing cables in a wide range of applications. By following the NEC requirements, industry best practices, and the manufacturer's instructions, one can ensure a safe, reliable, and maintainable cable tray system. Remember to consult with qualified professionals and local authorities to ensure compliance with all applicable codes and regulations.